All right, we're going to start in section, actually it's 1.2, it's not 2.1, so let's clear that up. 1.2, looking at the basics of functions and their graphs. Okay, and first of all, we're going to look at what a relation is. Okay, a relation is any set of ordered pairs. So as long as it's an ordered pair, as long as I have a pairing of values, we consider that to be a relation. The first component in a relation is called the domain. And the second component is what we refer to as the values of the range. Okay. So what we have listed here is a table, a kind of pairing, a relation between TV celebrities and their earnings per year in millions of dollars. Okay, you see we got Oprah coming in at $315 million, Simon Cowell and Dr. Phil at $80 million, Ellen DeGeneres at $55 million, and Ryan Seacrest earning $51 million. Okay, so what we're going to do is we're going to look at see how can we represent that table as a set of ordered pairs. Okay, so we can kind of convert that table into a set of ordered pairs by writing an ordered pair out of each one of those celebrities. Okay, so Oprah earns 315, so that is one ordered pair. Oprah is part of the domain, 315 is part of the range, and so forth for the rest of the celebrities. We've got Simon at 80, Dr. Phil at 80, Ellen at 55, and Ryan at 51. Okay, so if we wanted to identify the domain of this relation, the domain is going to be the set containing Oprah, Simon, Dr. Phil, Ellen, and Ryan. The first component of each ordered pair is part of what we call the domain. The range is the set that contains the second element of each ordered pair. 315, 80, 55, and 51. Now notice that 80 showed up twice in our ordered pairs, but when I'm identifying the values in the range, I only have to list it once. 80 is a value of the range. The fact that it happens for multiple people is irrelevant. It's part of the range, it's one of the values in the range, so I don't have to list it more than once. State the domain and range of the set. So look at the following set and see if you can identify the domain and the range. Okay, so the domain is the set containing 0, 10, 20, 30, and 40. The domain is the first element in the ordered pairs, the first component of the ordered pairs. The range is comprised of the second component, 9.1, 6.7, 10.7, 13.2, and 21.2. Okay? So those are the components, those are the elements that make up the domain and range of this particular set of ordered pairs. Now to take this one step further, we can talk about a function. Okay? A function is still a relation, but it's a special type of relation, and it's one that we look at extensively throughout this class and throughout mathematics. A function is a relation that we call one-to-one, meaning for every element in the domain, there's only one element in the range that it will correspond to. So if you look at the diagram that we have drawn here, okay, you can see that 1 corresponds to 6. 2 also corresponds to 6, but that's okay. Each element is only going to one place, 3 to 8, 4 to 9. So every element here in my domain set is only going to one place in the range. I don't have two arrows coming out of the same value in my domain. Okay? That tells me that I have a function. Everything in the domain matches to one thing in the range. And it's okay if different domain values have the same range value. Okay? I just can't have more than one arrow coming out of a domain value. So if we were to kind of switch those sets around, but kind of keep the same pairings, you would see now if my domain contains 6, 8, and 9, I have the value of 6 corresponding to two different values in the other set. 6 is going two different places. So the fact that 6 in the domain goes two different places in the range tells me that this is not a function. It is not one-to-one. I don't have one value in the domain matching up with one value in the range. I have one value in the domain going to two values in the range, which means this is not a function. It is still a relation, it is just not a function. Okay? So in example 2, here's this set of ordered pairs. Is this relation a function? If it is, why? If it's not, why isn't it? Okay, why not? So take a minute and look at that. Well, if we examine the ordered pairs, we can see that the last two ordered pairs, the first component of each one is a 5. But in the first ordered pair that has 5, I have a 6 as my second component. So my input of 5 is giving me an output of 6. And in the last ordered pair, I have an input of 5 giving me an output of 8. So I have one value in the domain going to two values in the range. If I were thinking of this in terms of the diagrams like we had before, here's my domain. Here's 6 and 8 over here in my range. I've got 5 going two places. One value in the domain goes to two different range values, says that this is not one-to-one, and therefore it is not a function. Okay? The fact that it is not one-to-one, I don't have one value of the domain going to one value of the range. I have one value of the domain going to two different values in the range, tells me it is not one-to-one, and therefore it is not a function. Moving on. When we talk about an independent variable, an independent variable is just that. It's independent. Okay, you can be assigned any value. I can, and oftentimes I can make up whatever I want it to be. And those independent variables are what we call the variables in the domain. On the flip side, we have dependent variables. If it's dependent, it means it depends on something. And what does it depend on? It depends on what the independent is. So the dependent variable, which is going to represent the values in our range, those dependent variables depend on what values have been put in. So it depends on the independent variable. If I change the independent variable, I'm going to get a different dependent variable. Okay? So the independent variable represents the domain, and oftentimes we think of those as our inputs. What are we allowed to put in? And the dependent variable, those represent the values in our range, and we oftentimes think of those as outputs. What are we going to get out after we put something into it? So in example 3, we want to look at these equations and decide, do these equations define y as a function of x? Meaning the y values are dependent on the x values, and if I put in one x, I'm only going to get one y. Okay? So to do that, we're going to solve the equation for y. So if we look at example A here, and I solve for y, I'd have y equals 4 minus x squared. So the question is there any way that I can put in one value of x and get two different y values? Okay? And in this case, the answer is no. Okay? This represents a one-to-one relation. No matter what x I put in, I'm only going to get one particular y value out. Okay? So in example A, we do have y is a function of x. Whatever I put in for x will determine what I get for y. Okay? And there's only going to be one value for every x. If I look at B on the other hand, and I solve for y, I'd have y squared equals 4 minus x squared. So if I take the square root of both sides, then y becomes plus or minus square root of 4 minus x squared. This plus or minus out here is what causes the issues. Okay? If I put in one value of x, if I put in 0 for x, then I'm going to have plus or minus square root of 4, which gives me plus or minus 2. Okay? So I put in one x, I put in 0 for x, and I got two different y's, one positive and one negative. Well, that is not one-to-one. Okay, which means this is not a function. y is not a function of x, because I could put in one x value being 0, for example, and get two different y's. Well, one x matching with two y's, that is not a function. Okay? So tomorrow in class we're going to look at some problems looking more at determining the domain and range of a function, looking at what is independent, what is dependent, and taking a function and deciding, does that function represent y as a function of x. Okay? So we'll see you then.